voice of God or something.
The voice of God.
You mean my echo?
Yeah, your echo.
Yeah, I don't want to mess with I don't want to mess with Nathan's earbuds, so I just left it alone.
Yeah.
And I turn on my camera, but apparently I'm, just not here.
Yeah. Before you guys enter a heavy debate, can I present my stuff first, like usual?
Yep.
By all means.
Okay.
Thanks. Share screen. Enter your screen. There you go. Boom. First, I want to start by saying that C++ Superset version 2.1.0 will be released early next week. I'm super damn happy about it because it's going to be very powerful. It's a software that makes other software crash-proof and free from memory leaks, and it's very fast. You're not slowing down the application at all, so it's pretty awesome, and I'm really happy. I've been working for a long time, but the next version is going to be extremely robust and powerful. So sorry about that, but that was my sponsoring for tonight. Other than that, I want to say that Sabine Rosenfelder was talking about the science, the academia, the scientific system, that they now use AI. They now use AI to publish a tons of useless papers, so that they can get grants, and it just maximizes all this system already was. People, they just publish useless papers just to get grants, and that's all they care about is the grants money. And they can make it as complex as they want. They don't care if it works or not, as long as it gets published. So the more complex it is, the more likely it is to be published. Contrary to what even if it's not, there's no experiment to prove it. The other thing I want to say is I can't prove it, but that I got plagiarized or not, but somebody else came up with exactly the same idea that I was saying since the last 15 years, that the galactic rotation, the galaxies, they have their own spinning framework, like I put it this way. But that guy here says that it's like a galactic pizza that has its own spin, so that would explain the galactic rotation curve while ruling out dark matter. Well, I was saying exactly the same thing, and I can prove it using a paper in my archive paper on Wayback Machine, dating back from 2024, where I talk about the galactic rotation curves. It's a big paper, but right here, the galactic rotation curve. See, the equation is very, 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 very simple, and I just had a little spin here. The omega is a little spin that I had, which is exactly what the galactic pizza is. And then I compared my theoretical finding with the observation with 500 galaxies, and I get exactly the same thing. We're very, 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 very similar. And but it's just extremely hard to publish because there's so much bullshit in the journal these days that they're not interested into fundamental physics anymore. The other thing I want to say is that dark energy was I also did rule out dark energy using time dilation to explain the expansion of the universe. And somebody else also came up with the same idea last year, and they called it timescape. The timescape theory here. So it was proposed in 2007. So I had the idea in 2009. So I can't say it was plagiarized. If it's true that he came up with it in 2007, then obviously I didn't know about the theory back then. But anyways, we had the same idea with that dark energy, that time dilation, time contraction actually rules out dark energy. So right here I'm explaining it. Right here using the Hubble law, you know, acceleration of the visible universe, blah blah blah. And I talk about the position of the universal core. But I had this idea in 2011 and first 2009, sorry, and yeah, so yeah, so yeah, that's what I want to say. So yeah, I'm all done. It's it's I don't take a lot of time, but what I'm saying is very dense. So you're welcome to comment on what I just said.
Well, the thing is, there's so many physicists out there that have their own theories, and a lot of their theoretical science, a lot of it hasn't been proven. You know what I mean? So it's a theory. So it's like, yeah, you could be right, but then again, you could be wrong until you actually do a physical experiment or some
Yeah,
kind of to give you some evidence of your theories, right? That's why, like, I build my projects, right? You know, I have an idea how I think it works, but I have to build it first. I have to make it run. And
yeah,
if it works the way I think it's going to work, and I'm correct, then I can start working on the physics of it.
yeah.
And
That's why I figured, well, at the macro scale, you can't prove anything, at the size of the galaxy. So
well,
it's more
basic.
beneficial to work at the nanoscale because you can create experiments
See,
more
like,
easily. You know what I mean?
there's one thing I did learn today is when you get down to the macroscopic level of matter, the theory of relativity falls apart.
Yeah, it falls apart or outside the solar system, so
Yeah,
it doesn't
completely
explain it
falls
that
apart.
much.
Right.
Yeah,
So I think it all boils down to our perspective of scale,
yeah.
right?
But
Because
the thing when Einstein wrote his theory, he didn't back then. They didn't know about they thought that the universe consisted only of the Milky Way. They didn't know that it was as large as it is right now. So that's why Einstein didn't really care about the expansion of the universe when he wrote his theory.
yeah,
You know?
because it boils down to what scale are we talking about? Are we talking about quantum or are we talking about galactic? They're two different
Yeah.
scales.
Yeah.
So
Exactly.
when you get down to quantum mechanics and quantum theory, well, obviously, right now, from what I've been reading on, is the theory of relativity starts to fall apart.
Yeah. Falls apart at the micro scale and the nano scale, so it's
Yeah.
not very useful at
So
the end of the day.
yeah,
Well, hold on.
it,
If you say that we're traveling through space, right, and you have our solar system here, XYZ may work for the solar system, but it doesn't work when you start hurtling it through space in its own rotation. Okay, or
Yeah.
even if it's a rotation this way, and then you get into what's the rotation of that? Is it a torus that we're going around in? Is it a spiral? Is the center of that? What are the rotations of that? So you have extra dimensions in there. That's why string theory is working instead of just
yeah.
the space-time in this, because you have more vector dimensions than you think you do, because you don't realize we're hurtling through space. As soon as you realize that, then you realize that there's way more than what you thought there was.
Mm-hmm.
Yeah, but I think the string theory, it says that, or the superstring theory says that every atom is an universe or something like that, and you can scale it up this way. But I might be wrong. I haven't read about it for a long time, but
I think.
Yeah, go ahead.
I think string theory might make a little bit of a comeback because.
Yeah, I don't know. The author says its own author says he didn't have experiment to prove it. So
yeah,
that's just because they're telling you about a wobbly string instead of telling you about the resonance first. They forgot they forgot to look at the tuning fork, and it goes in and out. It's two frequencies working together to make the resonance that comes out of it. So you have to take that into account. If you're looking at string theory, you cannot just call it a string out in the middle of nowhere. You have to understand that there's a pulse and an impulse to everything. That makes string theory work. But if you don't have that, then it just seems like you're plucking a guitar. But if you start the frequency, the guitar plays itself. You don't have to even pluck one string. It'll just turn on because it's matching the frequency of resonance to the single frequency that's out there. It's exactly how Tesla coils work. When you don't connect anything else to a number 2 coil out there, it's basically a string, and it goes off and turns on and creates null zones.
Well, I'm just about done my 5th Tesla coil, so I'm going to test that theory for you. I have not seen a null zone in a Tesla coil, and I want to see what you're seeing. So.
Well, a single Tesla coil is a monopole. It won't show you. I
don't know about that one. I would disagree with you.
Well, I can tell you because the primary and the secondary start in the same spot. It can only build one direction, and anytime you put something on there, it'll only show you north as direction. The second thing is when it builds out to the next one, it builds in a bipolar fashion. There's always a null zone in the center. You cannot connect it to the primary Tesla coil. It has to be just a number 2 coil by itself that turns on based on the resonance frequency of oscillation of the primary driver. Then that frequency itself has to be on the frequency of that coil by itself, that number 2, or else it will not work at all. And I prove it out on my channel several times.
I've watched your channel, and I've been following it, and I want to test this Tesla coil theory, because if it's that simple, then everybody should be able to do it, right?
Well, yeah. As long as you remember it's a frequency and resonance, not what you wound it as.
Oh, I know resonance, dude. When I wind my coils, they're resonant the minute I pulse them, the very first pulse, because of the way that they're designed. I know all about resonance. And string theory? Shit, I'll get my banjo. Just kidding. You gotta smile a little bit. Come on, you guys. There's your sense of humor. You're killing me here.
By the way, Michael, I want to say thank you for sending me that information, man. That TUFTS, that was the best thing, by the way.
Which one?
The TUFTS. I don't know the actual name of it. Tufts?
The little thing that the mechanical thing that goes back and forth, or
no. The energy's there, but you can't really see it. So it builds out in different things, and it builds out in the negative and the positive, the cold. You know what I mean? There was a whole video on it when you pulled it up on the internet.
Oh yeah, I mean, there's so many things I've looked at recently. So unfortunately, I've already.
No, it's fine.
That. But I'm glad it was helpful.
Yeah, it was based on Sean's little plasmoid thing he's making. Right.
Yeah. Well, these days, what I'm most interested in is, are you guys familiar with the what's the guy's name? There's like a high IQ, the website highiq.com. What was it again? Clever name. Let's see if I can get it.
TopIQ.com.
Nope, not that one. And I think maybe my internet's unstable, so maybe. Oh no, it's this one. Good. That is the one. So he's got a very interesting theory. We got to customize the cookies here. Okay, good. There we go. There's the chat, and now I can share the link. Anyway, I don't know if you've seen his website before, but someone pointed it, sent it my way. and I was quite fascinated by the concept. So what he has is he has two coils. They're not quite in bucking mode. So you have two coils with opposite chirality. So it spins this way, and then it goes, there's a straight center tap, and then it spins the opposite way. And based on the timing, I mean, maybe some of you guys have heard this before, but based on the timing, basically what you have to do is you change how the thing is wired as it's resonating. And you can do this with a diac or a triac. There's components that'll modulate the impedance with respect to time. And so when a coil, I mean, you guys can try this experiment. When a coil has very high impedance, when it's not shorted through a load, when the coil's an open circuit, you can wave it by a magnet and it'll be impeded a little bit, but it's not going to be like impeded a lot. When you short that coil, now it's going to resist motion a lot more. Same thing with the field applied. So you can pump that coil up to some high voltage and then switch it from a high impedance, not connected state onto a load. And then when you do that, and you have this arrangement with the counterwound coils, so you have your pump, you get these at some high voltage. Maybe you can even drive it capacitively. So you get these to a high voltage somehow, and you switch off the driving and you remove the driving, and then you take this thing before it's lost its voltage and you put it on a load. And then these two coils fight each other, and this thing rings down. These two things, like, they fight each other, but the way they're wound, the currents and the voltages add. The magnetic fields cancel, but the currents and the voltages add. And so you end up getting a ring down, which is linear with respect to time instead of exponential with respect to time, based on the requirements of electrodynamics. When you put a magnet down a copper tube, it will accelerate until the force on until the force from the EMF on the tube is equal to gravity, and then it will fall at a linear rate. And so when you have these coils in bucking mode, it falls off at a linear rate, but the amount of energy stored in an inductor is defined as what it has when it falls at an exponential rate. So there's a difference in the area under these curves, and the difference in the area under those curves has to be endothermic. So it's driven by the thermal energy in the system. And so that's very fascinating.
I know exactly what you're talking about. It's actually kind of how my system works.
That's
how you change the temperature.
Yeah,
If you change the temperature, you're gonna have different effect.
So I think I'm starting to understand it then.
Well, the bucking coils, my coils don't buck, but they are wound 180 degrees out of phase geometrically.
Exactly. It's not quite bucking. It's bucking with your bucking coils are wound the wrong way around. You have to flip one of the coils, and then the voltages and currents add, even though the magnetic fields cancel.
Yeah, it's constructive interference all the way. I can pulse my primary and my secondary, which are wound 1 for 1, 180 degrees out of phase. And I double my output because I fire the first one, then I fire the second one, and it's very evident. I'm now communicating between two coils across the room from each other.
Yeah. Well, I mean, you guys, Gerald, I don't know how formally you've been trained with this stuff, but it looks like there's in the literature, this is described very subtly. There's a few papers. I can even send some of them. But the literature, there are people who looked at this. They mentioned, oh, this is an open system and it's over unity in a very subtle way, wishy-washy, but like it's there in the physics literature already, in fact, if you know how to find it. So they call it Dicke superradiance. So there's something called the Dicke-Maser model, D-I-C-K-E. He invented a lot of magnetic stuff. So the Maser model basically describes if you take a magnet and you flip an external magnetic field. so that the external field is down and the magnet's polarized up. Especially if you have a soft ferrite, then you effectively have a population inversion in the ferrite. And so with the external driving field opposite to the magnetic field of the ferrite, it's possible for the ferrite to actually emit radio waves.
I actually have 12 ferrites that surround my coil, and I just came up with a new circuit where the drive circuit can run for 3 weeks before it even goes down 1 volt on the meter.
Nice.
So I'm now charging 12 batteries, and the system itself can run for 3 weeks thus far. I'm still testing. So it's pretty crazy, this stuff. I'm at that stage now. So when it comes to Jack Sarfati and Jeremy Reese saying there's no free energy, no, there's no free lunch. I still have to pay a little bit. But what I'm getting back is exponential. Like it's amplified times 12.
Well, it's not like free energy, like 0 point energy, like in the past 50 years, but it's thermal energy recycling via non-equilibrium steady state open systems. And you can look up all those terms, but that's why Sal was so excited about Ilya Prigozhin's work, because Ilya Prigozhin's work points out that you can have, in fact, if you look at Ilya Prigozhin's textbook, it's right there. These things are like right in the open. I'm surprised. But yeah, if you get Ilya Prigozhin's thermodynamics textbooks, he goes from Carnot engines to open dissipative systems. That's like the title of his book, and it's right there. So open dissipative systems are the next paradigm from Carnot engines in thermodynamics, and we have to redefine thermodynamics. We have to go back to StatMech for non-equilibrium open systems. And anyway, sorry, I didn't mean to interrupt, Gerald. Go ahead.
Michael, I'm trying to find a theory that fits the system that I've come upon, so to speak, and there isn't one. There's bits and pieces of everybody's theory.
I'm telling you, this is it.
Okay, well, it goes a little deeper, and I really don't want to relinquish where it goes to because of the sensitivity of the data. I'd like to do a Zoom privately to tell you where I'm at, and it has to do with the Atoms project. It gets so much deeper than you think. It's not just.
No, I have a pretty good idea. Well, actually, I am curious. That does make me curious, but I have a pretty good idea. I mean, it involves the Wu experiment, and so you have 2 counterwound coils. So you break CP symmetry, and that implies you're breaking time symmetry if you want to conserve CPT symmetry. So
I've done time experiments that documented video. I even have people that have written affidavits on it. So there's stuff we need to discuss for sure.
Sure. Yeah, I'd be happy to collaborate in some capacity. We're just getting into this, but I see how I can translate the existing literature to your project, hopefully. But
I think it's going to take going over a few separate theories and mashing them together in order to figure out what's going on, because there's 4 fields of modality with the system that I've created, and it does things that 2 of the fields of modality I won't even discuss on live because I don't want people knocking on my door.
Right. Fair enough.
But I have no issues going to the scientific community and having it checked over and looked at, because I'm now at the stage where I've copied everything 3 times. I have dead man switches. I'm not worried about it disappearing. So
good.
I'd love to get to the point where now it could be, I wouldn't say peer reviewed because I don't have a PhD. You guys aren't my peers. But at the same time, you being in the scientific community, you can write papers on this stuff. And then
at the very least, we can translate it so that it's palatable to the current scientific community.
I'm already at the stage where elements are. We can get into that in a future Zoom talk.
Right. But yeah, I mean, elemental transmutation, that's something you might expect under certain circumstances.
Yeah, there's a few components that are added. I switch out a few circuits, and there's some. It's called the Atoms Project, is what I actually call it. But we could get into that in the future.
Cool.
For
But
sure.
certainly-
I'll write a book on it. So I've been mapping this stuff for over 16 years. Like I've been. There's a lot to this. I have 8 binders of notes. I've written a book. Needs to be edited. I'm just about to release everything open source to the world.
That's
'Cause
exciting.
I have 5 devices that have been built, prototypes that run. So
Nice.
yeah,
That's exciting.
I'm at that stage now.
Good stuff, man.
Yeah.
The world needs it.
Absolutely, I totally agree, 100%. We don't want to get rid of oil. We just want to reduce its use to the point where it ain't gonna mess everything up. You know
Well,
what
I mean, it's still very useful for plastics and stuff, but like
lot
we
of
don't
things.
need it. We don't need it for energy. Not if
Nope.
there's an alternative.
Nope, we don't.
Do you
There's
have a PhD, Michael?
No. Nope.
Okay. But you can write papers.
Oh, I can certainly write papers. I've published before. I just had no patience for the politics in academia these days, so I just went into industry.
Okay.
Yeah.
Yeah, it's sad. It's sad. It's a little bit sad that the pick went all mainstream with all these PhD. That's why we all got sidelined, I guess. But that's it's better here, I guess, because it's every week it's more frequent. Our research it's get updated more frequently, than once a month.
Very cool.
Yeah. By the way, I was talking about the macro scale earlier, but at the nano scale, as you know, I also work on stealth propulsion, force fields, and antimatter genesis. So these things I can prove them more easily than the galactic rotation curve and the expansion of the universe. But just that I'm not gonna make. I did talk to the U.S. Navy about it, but they want my work to be public and peer reviewed. I said no way. I'm gonna keep it. I'm not gonna share that publicly. So yeah, that's where I'm at. So I'm trying to self-fund my own company to do to pay for my own research, and that's what I'm hoping to do with my software that I'm gonna release next week.
Right on.
So and for all the for all the beers gonna have to pay for also along my research.
Yeah.
Yeah.
Yeah, I was going to say, Nathan, one of our chat guys, you know who it is kind of pissing me off right now. I can't.
You need him out of there? Is that what you're saying?
Yeah, he's being a little bit of a dick. So
I tried to tell him to stop, Mike.
yeah, I would not. I can't do anything because he's coming off your channel.
All right, I'll take care of it. Give me a second.
Yeah, he's being.
Let's see how I can do it.
Yeah, right.
Yeah, if I want negativity like that, I'll call my ex.
Yeah, really.
If you need negative energy, yeah.
I don't know. This guy is something else.
Hey, that's a good experiment. You put your ex with your current wife, and you test the energy, and you test the
There's a lot of
gravity.
energy there.
Be a lot of heat, that's for sure.
Yeah.
Maybe some blood splatter. No, I'm kidding.
Oh man, you don't want to be in that energy. That's all bad. Like being in the sun. You don't want that.
I'm just gonna scoot out for a quick smoke, you guys. I'm pretty sure you can handle carrying a conversation.
Oh yeah, for sure.
Oh yeah, you know what? Mike does is right. I do have a ability to have other people come in just like me. You're right. Sorry. I don't mind having fun in the chat, man. I just don't like making fun of the host. So, ADX, thank you very much, man. Gifted 5 Old Man Builds memberships, dude, to my channel. Hey, check it out. If you guys want to see Sean's experiments, man's on there, on that little rab that he's building, and see exactly how his shorts and everything are going, so you can slow them down every way you want. It's on my members part of the channel. You can watch it. Totally cool experiments, man. Have you had a chance to check that out, Michael?
Sorry, I was frozen for a second there. My internet's a little unstable. What did you say?
Do you have a chance to check out Sean's Rabs that he's making? He calls them a little RAV.
Oh, unfortunately not. I've been super focused on my own work, so haven't been like on the web so much. But yeah, once I'm done getting out of the rabbit hole and stuff, got some research to show for it, then I'll probably branch out and poke my head above ground and see what's going on in other places. There's a lot already that's going on that I do know of, and that's just without looking even too much. Like there's the Unlab and Charles Chase. They're coming forward as of 2022, 2023, just a few years ago. And that's like Lockheed admitting that these energy technologies are real.
Yep. I've been watching that Charles Chase. You've seen his he does he's got a YouTube channel there. It's actually called APEC. And he's got all kinds of he's got Hal Puthoff on there. He's got you have to check it out. And he does a full breakdown of what he was working on.
Yeah, the Unlab there's a great conference. I hope they do more of it.
At the Unlab.
Yeah.
I'll have to check that out. Actually, I think I have the Unlab. Yeah, my bookmarks.
Yeah, definitely check their stuff out. I mean, that's all the thermal energy recycling stuff. That's the because like you could maybe harvest ZPE, but you may as well just harvest the thermal energy because it's much more easily accessible.
They both coincide with each other once you have the right system.
I know. They're somewhat interchangeable, but yeah, I mean the thermal energy recycling that just keeps it like less weaponizable, I guess, more useful as well.
That's debatable, but I understand where your head's at with that. I guess it would depend on the system itself.
Fair enough.
Like the efficiency that I've got it's stupid. I would say I have direct energy conversion personally, but
that's amazing.
It has to be tested. I can move my heat around. I can move my cold around. I cooled my room down at plus 32. I brought it down to 26, and all I was doing was testing with my coil.
That's wild.
Aluminum. Yeah, so
just careful with those fields because they're messing with entropy, and the body actually does need a little bit of entropy.
Oh yeah, I have a Geiger counter. I have tri field meters. I take precautions.
Good. But it sounds like we should definitely chat more. I think absolutely. if we can put what you're building in scientific terminology, make it palatable and explainable, as much as we.
Well, I've been learning your language, so you froze again.
No, that's because he's in some sort of a time dilation warp, you know.
There you go. He's in a time bubble. Yeah, you froze.
You froze,
Mike. I think I froze again, but yeah, if we can make it more communicable, it'll spread. I mean, if we can make it like easier to explain.
I've been learning your language, so as I was writing my book, you could edit one of the papers and see if you understand, or if I put the terminology into correct terms when you read the paper I scoot to you.
Yeah, sounds good. And so, sorry guys, I'm still my internet's cutting in and out, so my bad if I jumped around.
That's not a problem, man.
Yeah, so that's what we're kind of all working on some crazy stuff, but I've been kind of doing this behind the scenes, staying off the internet for the last, I don't know, couple months, I guess. Hey guys,
Dude, it's been like 6 months.
has it been since I've stayed off?
Dude, I think it. Well, you had a couple of videos. Don't get me wrong, but like as far as you did a live, what, about a month ago?
Yeah,
Maybe
about
a couple
month ago.
months.
Yeah.
But like as far as like every day or every week or you know what I mean, stuff like that. It's been a while.
No, I've been staying away from it because I've just been head to the grind working on this stuff because what I found, it needs to be looked at now. I'm at the stage where I brought it as far as I can, and I brought it pretty far. But it has to be looked at by professionals so that in order to make it completely safe for the public, it has to be gone over, right? Like I'm one man. I can't, what am I going to do when it comes to releasing this to the world? It has to be looked at by other people. And I took it to my university, and the physics professor there he didn't know what to think because he didn't believe in 0 point energy, and he didn't understand when I was telling him that I've achieved direct energy conversion. How? Because I don't know, maybe I was explaining it wrong. But yeah, I've been kind of keeping to myself, just working hard. That's all.
Yeah.
Getting her done. Like my house
Yeah,
is.
talking about long lost people, what happened to Jeremiah Pop? I haven't seen him for a long time.
I don't know. I haven't talked to Jeremiah Pop in almost a year and a half, 2 years almost. Yeah.
I think he's been very focused on trying to get experiments done within our group. He's spread himself. He spread himself a little thin on those projects. So, I mean, it is what it is. But hopefully, he'll get through it.
Yeah.
Cool.
Yeah, that's why I had to get away from YouTube for a while. I had to finish up on some projects.
Same.
Yeah. I've now watered, or I've set up my house so that my grow room, like I grow food in the basement, and it heats the water through solar pool heater, and that hot water goes directly to my hot water tank. So I barely use any gas to heat my hot water at all. And when the winter rolls around in the next month and a half, the ventilation from my grow room will go directly into the intake of my furnace, and that's going to kill my hydro bill as far as heat goes. So it's all about efficiency, right? You got to curb here, curb there, make it happen.
The whole west coast of Canada will talks about seceding from Canada.
Well, if you have an arbitrarily efficient heat pump, you can just pump the heat into your house for pennies.
Yep, I know. But there's some things that I have to get checked to make sure they're safe before I start using it for heating and the coils for heating and cooling on a regular basis. You know what I mean? Yeah. So now I'm just doing it through my grow room instead because I'm running two 1,000 watt lights, and those run off the battery bank that runs off my solar. So
awesome.
Save a lot on your electrical bill there.
Yeah, I mean, once you got free energy devices, that's the first thing to do is get off grid and suddenly just start selling energy back to the grid, maybe if they let you.
Not where I'm living, they won't. My solar's about to be obsolete, so I don't even know. I might sell that.
You could use the energy to produce something of value and sell that, then I suppose.
Yeah, maybe.
Well, I know.
When you need more energy, Gerald, I'll sell you antimatter. But be careful.
Antimatter.
Well, use it for free.
I don't want the antimatter. I want what the antimatter can do. I want to grow elements with that antimatter. So I don't want the antimatter.
Yeah, but be careful or the whole planet will disappear.
Nah, I don't believe that. They say that, but come on, man. Do you honestly think you're going to be able to stick antimatter in a bottle? Like that's I don't know. I'm not part and parcel of believing in dark energy and antimatter. It's just not my cup of tea. I've read a lot of the papers, and I don't know. I don't aspire to teach their own, but if I had antimatter in a cup, what's it gonna do? Like, you're gonna blow up the universe just because it's sitting in a cup? That's a lot of freaking energy in one place. You know what I mean? I don't know, man. Just
A little bit overkill.
yeah. But I don't doubt that you can make it. Like, if you say you can, man, all the power to you. But I don't want it. I'm good. You know?
Do you think the antimatter could create, if it's made out in space, do you think it could create like a small wormhole or a portal? Because the only thing that's going to eat up, it's going to eat up whatever is in space. So if it's going to eat the fabric of space itself, it might open up a
I'd leave
portal.
that one to Michael, because I don't know. I'm not an antimatter guy. I have no idea.
Yeah, me, I don't believe in portals, but but so I cannot. I would say no to that.
If
but
portals
I'll
are
let
possible, it's a little more complicated than that.
Yeah.
There's
Well,
a
I mean,
lot of-
what I'm asking is, antimatter eats up things. Well, if it eats up whatever there is, then what happens in that space?
well, it eats up matter and emits gamma rays. I mean, at least in the standard model.
Electromagnetic.
But like, if you're talking about portals, now you're talking about entangling distant parts of space negentropically, which you can do with the negative energy things, and like, there's.
I don't know about portals, but I'm finding that communication at a distance instantaneously, thus far, seems to be possible.
Yeah, that's possible. That's
If you got time travel, you got that automatically.
yeah,
Oh.
but quantum, and you're talking about quantum and quantum tunneling. Quantum tunneling is badly worded because it's not really a mini tunnel. It's just fast FTL particle for me. It's just something that goes that goes faster than light for a moment.
Extended electrodynamics goes beyond quantum mechanics. There's a more general model. Some version of extended electrodynamics is true, probably, and if it is true, then then there's a lot of interesting possibilities that were not possible with quantum mechanics that become possible with extended electrodynamics.
Here's a small experiment for you, Michael. I take, we'll call it a vortex coil, okay? So I take vortex coil A, which is bipolar, and I put it on one side of my room. And then I take vortex coil B, and I put it on the opposite side of the room. Both of them contain a rod of ferrite with 120 wraps of copper. I'll pulse the primary of coil A, and I will get the energy in the secondary of coil B. And it's from across the room. And as far as I can tell, there's absolutely no delay. So does that go to faster than light communication, or do I have to have more of a significant measured experiment? You understand what I mean by that?
Oh, was that for me? I was.
Yeah, that was for you, actually. That was for you, Michael. Did you catch that?
Oh, it froze again. Sorry, I've been having a little issue with the internet connection.
Okay, so I take two vortex coils. Each of them have ferrite cores with 120 wraps on them. I pulse primary of coil A, and it's across the room, and I pick it up in the secondary of coil B, and there's no delay. You're muted.
Sorry, yes. What's your so your oscilloscopes, how fast do your oscilloscopes go? Do you have some means of connecting those oscilloscopes and do you actually know that there's no delay within those oscilloscopes after you've moved them into their positions?
Good point. All I have is handheld oscilloscopes, so you're right. I may need to get something a little bit more
You
elaborate.
need more sensitive equipment to tell that
Yeah.
for sure.
Okay, that's good. Good to know. That's why I wanted to ask.
Yeah. Yeah, that's ideally you do it optically. So the way I would do it is don't even bother with oscilloscopes. Just have so like if you cast a shadow on a wall, or actually if you have a laser on the moon, that laser can, if you flick the laser across the moon surface, it can move faster than light very easily, straightforwardly. So as long as you're constantly sending that light pulse, you know what the situation is. Well, actually, no, you can't communicate information that way. But basically, you can send a beam, you can send a laser across the room here, and if you have some high voltage on some coils, you can send that laser through a photorefractive crystal, electro-optic carapacal cell. You need it to be pretty small because the and Pockle cells have a refractive index, so you need to account for that refractive index shift. But now you have a prism made of these things, and you can bend the laser proportionally to the voltage at that place at that time. And so now you're picking this up with some laser interferometer that's built, and you can know 100% like what the timing is. In fact, you can send the laser pulses. Like you can have the laser pulses sweep by, what was it called again? There's these things they make in optical, like fiber optic communications. Hopefully I didn't cut out again.
Nope, we got you.
Good. So there's these things for fiber optic communications. What are they called again? Optocouplers. You can get optocouplers that'll go up to 10 gigahertz easily.
Okay, good.
So you can get a very fast optocoupler, and then you can use the optocoupler to detect the beam as it passes over based on the angle of the photorefraction thing. And that's at 10 gigahertz, which if you correlate that to like light speed, like that's it's like an inch about. Like if you're worried about an effect that's happening over a few meters that you think is FTL, then that should be just enough. That should be just enough resolution to tell you if it's FTL.
Okay, I'll have to rewind. That shows my age.
Oh yeah, but
go back in the video and get all that information and write it down and definitely make that setup.
We can chat about the specifics. In terms of electro-optic crystals, those can be a little pricey, but there's this guy Turtles Horde online. He gets like aftermarket scientific crystals and stuff and sells them for jewelry and stuff, but you can still use those for electro-optic applications, and they're fairly affordable. You might need to polish it to shape to get it to work, but for this particular experiment, it doesn't need to be perfectly optical quality. It needs to be good enough.
Okay, fair enough.
It just needs to be electro-optic and like on a jeweler's loop or something, like polished, and that'll be good enough for this experiment. And then the optocouplers are surprisingly cheap, like because they're made in such quantities, so you can get one for like $10.
I have some optocouplers, but I don't know if it's the ones that you're talking about.
Yeah, I mean the ones that I was talking about are higher spec a little bit. I always just go get them at the MIT flea market, but not everyone's got an MIT nearby.
No,
you guys have
Canada.
Dude, they once sold a Gemini space capsule at the MIT flea market. I wish I knew at that time. It was amazing. Like literally the original, like one of the original ones. I don't know how the professor got their hands on it, but
Wow,
that's crazy.
Yeah. It's always a fun time.
Hey, Michael, I've got a question for you. You were talking about FTL earlier, and I had a thought experiment. I'm just gonna share publicly because because I don't really care about. I'm not gonna make money with that stuff, but it's really cool to share publicly. You know the double slit experiment.
Yeah.
So you have interference between the photon and blah blah. One is constructive and the other, so you get fringes. The other is destructive, and you get fringes of white and no light. But when you have black fringes, where there's no light, what do you think happens to the energy of a photon? Um, so some say it's being converted into heat or something like that, but I don't believe in that. Do you have an idea, or I have
Well,
my idea, but I just want to ask you first.
so the energy of the photon doesn't depend on the energy at those specific locations. It's a wave function thing, but that's only according to the quantum mechanical model. I mean, there's stuff maybe that goes beyond the quantum mechanical model. It seems like extended electrodynamics may be real. If that's real in some form, because there's many posited claims for extended electrodynamics, not all are equivalent. But yeah, I mean, there's certain situations where you can have overlapping waves, and those seem to interact with a dilatonic mode. And you can also have overlapping spins, and those are, you know, when people talk about torsion drives and stuff, this is overlapping spins. That's why you have in that device that I was talking about, the super radiant Dickey maser, you have the spin going up one way, and then you have the spin going up down the other way, and you have these things going past each other. You have a relativistic effect on these coils here, and they have a relativistic effect on these coils here. You're producing shear on the relativistic superfluid. It's not ether, it's quintessence. So back in the day, they would say ether models describing like a solid or maybe some sort of photon gas. But a quintessence model in general is like a fluid model. I guess a gas is a fluid, but not the way they were modeling the ether back in the day. But yeah, I mean, basically there's some superfluid model. It's implied by the Higgs boson, which is itself Yukawa potential coupling, which only shows up in the, or originally I should say, shows up in the Ginzburg-Landau model of superfluidity. So that implies a superfluid vacuum in some capacity. Anyway, kind of long-winded, sorry, but spin things fast enough relative to each other, and you get shear in the vacuum. And if you can shear the vacuum fast enough, get what Salpais was saying is you hit the Schwinger limit effectively, and at that shear rate, every superfluid known to man so far, like superfluid helium, for example, every superfluid we know of has a maximum shear rate past which it becomes an ordinary fluid with viscosity. So if you can shear the vacuum fast enough, it can have viscosity, and then you can push off of it, you can interact with it, do whatever. And that's how torsion works.
That's a hypothetical. It's not, it's just a theory.
For now.
Yeah.
I mean, so on my end, I would have to say yes, but people have allegedly built these things already. And maybe Gerald has built something already that
probably
these principles.
But what would you think? Because I have a little theory here, and what would you think if I say that the photon? I mean, they're in an angle, but if I have the photon in a straight line and I somehow manage to superpose them in one straight line, and they have a destructive interference, then it's possible also that the energy is being converted into kinetic energy, so they go faster at FTL.
You're kind of right. That's kind of right. So when you have overlapping photons in free space and they're diffracting through each other, effectively when they're canceling out their electric and magnetic fields, the rate of change of the electric and magnetic fields is still non-zero. And that rate of change of the electric and magnetic fields also encodes physical energy. And so you can have a rate of change of energy, and that also encodes energy.
Oh,
Yes,
Yeah.
it
Michael,
does.
Because
Michael,
they
sorry.
already observed the dark photons. Well, they already hypothesized dark photons. Then that would explain some phenomenons as well. You can look this up, dark photons, and you're gonna find some papers. And they go FTL. Dark photons go FTL. So that I think that's it's a puzzle that sticks together here.
Yeah, Michael, I
Well,
just wanted to show you real.
it froze again. Sorry about that. What was it? Last 30 seconds?
Yeah, I was saying that the dark photons go FTL. They already, you can look it up. Dark photons that go FTL would explain a lot of things, and that's what that's what I hypothesize
Well, that's
before looking that up. That dark photon would go FTL.
well, there's
Yeah,
something
Michael,
called the squeezed vacuum state. It's kind of like a dark photon, but it goes at the speed of light. It looks like you have something you want to show.
Yeah, I just wanted to show you my self-recharging battery
Neat.
technology.
What's it do? How's it?
It's a battery technology I've been working on for the last 2 years, and you can put this on a load for several days, and then disconnect the load, and it'll self-recharge itself within about 30 minutes.
Nice. What's the battery electrodes on that? Is that
So I got a high-grade carbon graphite plate, and then I got a copper on the other side, but inside I can't really talk about. I'm under NDA right now, so as far as what's going on inside.
I could testify that his crystal cell works because I've been talking to him and he won't give me his formula, but I'm doing something similar. I'm not getting as much as him at all, but I'm seeing the things that he's seeing. So
yeah,
100% I'd back him up on that.
Wow,
Yeah.
that's interesting.
Yeah. I'm getting about anywhere from 2.5 to about 3.2 volts per cell.
Okay, what's the wattage though?
Wattage, I can get a stack. Say I get a stack of say 10. I'm getting about probably about 13 watts.
13 watts. That's not bad. 10 of them that size?
Yeah.
I see. Okay, so it's not as much as a battery per se. Oh, do you happen to be working with Daniel Sheehan?
No.
No, you're not. Okay, so not that team. Liquid electrolyte, I imagine, or is it solid?
It's more of a solid state.
I see.
Yeah.
So that's not Daniel Sheehan's approach.
Yeah.
Interesting. Yeah, so there's crystal cells that sort of do things that I've heard of. Most of them seem like galvanic cells. Galvanic cells can last hundreds of years because the corrosion rate is so slow, but it's still corrosion. Right. But they don't get that many watts.
Yeah, it has to do with the alkaline level. So if your cell is say within say 7 alkaline, it could last 20, 25 years. Now, if I were to get the acidic level down to say like a 6.0 or 6.5, I'm going to get more output. Like I've made cells that put over 500 milliamps. I've had some go over 1 amp. So it depends on the alkalinity of your cell. If it's more acidic, obviously you're going to develop more current, but there's a trade-off. You're going to lose the longevity.
Right. So you still has a finite lifespan. If you replaced it with silver, would it still work?
Oh yeah. It would actually work even better. But silver is hard to obtain in the form that I need it. So,
well, what about silver coated carbon black?
I could experiment with that. See, the graphite that I'm using is very difficult to do layering or fabrication on it. It's a high grade carbon graphite that they use to cool off the nuclear reactors. A friend of mine actually has a contact in Canada, and he supplies the nuclear reactors in Canada with this graphite material that they use to cool the reactor cores.
Very
So
cool.
it's yeah, it's pricey. It's expensive stuff. So,
Gotcha.
but yeah, I've built pretty much every kind of crystal cell you can imagine.
Nice.
I've got this one design that seems to be pretty good right now. Doesn't have as much current as I would like it to have, but I could obviously change, the chemistry inside to increase the current output.
Well, I wish I could learn more about that so I could assist in developing it further. But you got your NDA, so that's the end of that. I can't help much more than that. Maybe with a little intuition, but
yeah, like I'm not the only guy that's working on this stuff. There's a lot of people out there working on it, right? So it's just a matter of getting the right materials, decide on what sacrificial cathode you're going to use in your cell, and then
does it have to have a sacrificial cathode? I thought it would have a sacrificial anode.
Or sorry, anode. My mistake. It can't. You're looking for a differential, so it has to be two different materials. You could use aluminum. Aluminum actually gives off quite a bit of ionic release. I've gone through a few of them. Some of them work a lot better, but they're unstable. Like potassium or calcium. They're highly reactive metals, but very dangerous to work with. So that kind of eliminates the upper tier of the group 2 reactive metals. So you have to go through them all and just find out what combination works right. I've pretty much
settled. But you're gonna want to rule out galvanic corrosion. So like, if you're studying an effect that's like a crystal power cell, you want to use metals that are as unreactive as possible.
Right.
So, for example, I recommend you try out like some nickel alloy and bismuth or something, because nickel and bismuth are not particularly reactive, but they have a large difference in their electron work function. And if that matters to the effect, you might see a voltage through them, even if there's literally no corrosion on them.
Right. Well, the cell that I have right now is pretty well alkaline. It's about 7. So, just over 7. So, the rate of corrosion is very minimal. If I were to make the solid state electrolyte more acidic, obviously it'll have an effect on that metal. But it's a matter of finding what you want. Do you want a lot of current, or you want to keep a voltage with longevity, or do you want to have it high powered with less longevity? So it all depends on what application you're really going to use it for in the long run. So I'm looking for that kind of happy median. I'm trying to zero in on that. So, but these ones here, like the group of cells that I just made, these were made about 6 months ago, and they're still working really good. So,
yeah, dry galvanic cells can last hundreds of years.
Yeah.
The power output, the amperage is usually lower when they last that long.
Yeah.
But it's still possibly galvanic. So that's something you got to look out for. At 13 watts, that's a lot of power for a galvanic cell. So I don't know. You may have a shorter lifespan due to that for the cell, but
there's quite a few cells that I've actually opened up to check out for dendrite formations and stuff like that. So I've got it to a pretty good level right now where the dendrite formation is almost non-existent. So yeah, I've come a long way. Like, I've been working at it for 2.5 years. Like, there's a lot of stuff I like to discuss, but I can't really, you know what I mean? So I gotta be careful.
So the optimal way, by the way, there's they already did this for magnesium ion batteries, but the optimal way to do dendrite mitigation is to use I think it froze again.
No, you're good.
Oh, okay, cool. the optimal way to do dendrite mitigation is to coat the surface with a bilipid layer, like in a cell, and have a ton of what's it called? Crown ethers
Nice.
and what's it? Ionophores. You want ionophores in there because if you have the bilipid layer, that will modulate where the crystal deposition goes, and the ionophores extremely efficiently conduct metal ions from a surface. Extremely efficiently. So there's that. And for multi-ion things, it's best to have a liquid electrolyte so that if you have an aluminum ion battery or a magnesium ion battery, if you have a multivalent ion and with a solid polymer electrolyte, it's not going to diffuse into the metal and get to the other anode, which if you're making a crystal cell and you don't want galvanic corrosion, maybe that's the best thing to use is multivalent ion, because multivalent ions get stuck in solid lattices. They don't diffuse through.
Yeah.
So things to think about, but it's I haven't gotten deep on the crystal cells myself yet. I think we will have better means of harvesting energy in other fields, but I think the more methods we do have, the better. So go ahead. Like, it's just like there's only so much ferrite in the world. Although iron is really common in space, but certainly the more ways we have of doing things, the less constrained our civilization is in the long term.
Yeah.
Absolutely. Put out 1,000 ZPE devices, all different.
Yeah.
Sure.
But just to go back to what I was saying earlier, if you admit that if the speed of light is not the universal limit, that you can go at speed of light, then you can, and that light has can have kinetic energy, then you can explain the annihilation process and the pair production very easily. I'm not going to talk about it because I'm under a self NDA about it. That's how I explain the antimatter genesis. But just to let you know that it's easier. I think my question was if I think that the black stripes of a double slit experiment go at FTL, do you think it's possible to measure it? You just talked about measuring FTL to.
I haven't looked at the dark photon stuff enough to know. Sorry, that's just out of my field of expertise.
Yeah, I posted a link in the chat, by the way, in the private chat.
Yeah, I won't be able to read that fast enough to get you an answer right now, though.
Geez, I thought you were fast.
Not a good answer.
I thought you
well,
were quite fast.
I could do a quick look. I'll see
Yeah,
what
I'm
I
just
can.
kidding. I'm just kidding. Just trying to be funny here.
You're funny.
But yeah, but you get the idea of what I'm saying. But if you know a way I could measure the speed of dark photons, that would be awesome.
So this paper looks like it's talking about axions and dilitons and stuff. So, I mean, what, roughly speaking, David Chester and I have been looking at for extended electrodynamics is the full Einstein metric has a symmetric traceless terms, which correspond to standard gravitons. You have the trace, which corresponds to dilitons, and you have the antisymmetric terms, which correspond to axions. And so right now, the big thing in the field is, at least in string theory, they've been looking at axions and dilitons for years. But axions and dilitons don't need string to exist. They work with the math of general relativity and to some extent with electrodynamics. And extended electrodynamics makes them work better with electrodynamics. So really, that's the way to unification, is to look at axions and dilitons. So this dark photon paper is talking about axions and dilitons in some sense. I don't know if it's in the correct sense, but certainly the place to be looking for new effects is with axions and dilitons. The axions relate to the torsion and then the spin, and the dilitons relate to like a compressibility of space.
Yeah.
So those are the other polarizations, I guess, of the graviton that haven't actually been factored in to the spin 2 model. Well, calling them polarizations is not exactly accurate, but they're the other terms in the metric tensor that have been left out so far. So those are the only possible 3 terms, in fact, that you can have once you have the anti-symmetric, symmetric traceless, and the trace, you have all of the elements of your matrix for your tensor, your stress energy tensor. But anyway, in terms of dark photons traveling faster than light, I'll take a quick look and get back to you here. I am skeptical, but I don't know the field, so I'll give it a shot.
All right, cool, thanks. By the way, do you talk to Dr. Chester? He likes like theoretical stuff a lot, so.
Oh yeah, he's trying to get more experimental actually, because none of the other theorists know how to do experiment, and he's kind of getting fed up with that.
Cool.
Isn't he out here in California?
Yeah, he's in LA.
I think so, yeah.
No, it's probably like 60 miles from me.
Yeah, maybe.
Yeah, he studied at MIT and he's in LA right now.
Yeah, I've seen some of the stuff. He's got like a vacuum chamber that he bought a little while back, and then he had a gravity flyer. He's got a couple different things.
Yeah. Yeah. So.
Are you suggesting that the dark photon could be the expansion fabric of space? I mean, if it's faster than light.
No, for me, there's no space-time fabric. I mean, if think about it, Einstein says that there's no ether, and then he says that later on he says there's a fabric. So make up your mind. It's like the same thing. So there is an energy density, but it's not curved or anything like that. It's just like there. It's not the space-time curvature was just invented because of the light bending. But Robert Dickey, me and later on I figured that Robert Dickey already explained the light bending without the space-time curvature. You don't need to curve space-time to explain the light bending. All you need to do is add time dilation to the already existing Newton acceleration, so you're gonna double the light bending. So, but to go back to the dark photons. Dark photon is just photons. Photon for me, it's just a positron and an electron entangled together that has it has matter, and it has a kinetic energy. It's very simple. It doesn't have a charge because the net charge is cancelled, is null, but it does have a kinetic energy because E equals mc squared. I mean, if a photon has energy, therefore it has mass. It's very simple. Einstein keeps saying that the photon has no mass because he wouldn't be able to explain the annihilation process properly.
So what
Okay.
what is a dark photon in your understanding?
It's a photon with low frequency, very low frequency, and it goes FTL or null frequency if you want.
So I mean, the paper that you sent me had tera electron volts, so that's gamma rays. So that wouldn't be low frequency by any means. But when you have extremely low frequencies, the near field extends a very far distance because the near field is like is roughly proportional to the wavelength of that light. So if you have a very low frequency, the near field extends out very large distances, and near field behavior is approximately um, elliptic or parabolic. I forget. No. Yeah, it's a parabolic partial differential equation approximately. And at the long wavelength limit, at the near field limit, yeah, I mean it's well known that things go FTL.
Well,
Oh yeah.
I can
Well,
tell
I
you
shouldn't
about
say that. I
this.
shouldn't say that. There's people who want it to not go FTL, but in experiments by Boeing, Aerospace, and a few other people, I think also Eric Dollard tried this once. Um, yeah, I mean, if you have near field, that seems to propagate FTL. Um, assuming that's not even the right term because it's the solutions to the wave equation. I mean, the solutions to the electromagnetic field equations for near field objects. The actual wave equation is parallel to the surface of the emitting object. So it's actually a near field object is actually a wave traveling on the surface. It's actually a surface plasmon, sort of. Well, that's for microscale stuff, but it's like a xenic surface wave on an object. And normal to the surface of the object, away from the surface of the object, it's actually obeying an exponential equation, at least according to the standard theory. Now, if we have longitudinal waves, those would have a wave equation orthogonal to that surface. But if we do have longitudinal waves um, in the far field, those would have a finite speed because all wave equations have a finite speed. I
So,
mean,
Michael,
they have for an infinite speed, it wouldn't be a wave equation anymore. Yep.
I did an experiment, and I've talked about this once on live prior, and this experiment included 5 separate people, and it wasn't supposed to happen this way, but it did. So I had turned on my coil system, and the secondary ran through a high voltage transformer, then through a neon, then it got grounded to the water pipes in my house. But I had those old steam radiators, and that's what it was hooked to. Okay. So I had it running at 432 hertz. And after about 3 minutes, so let me back up 1 second. I had heard that doing something like what I was doing might actually affect clocks. So I had set the clock in my office and the clock on my stove in the kitchen to the exact same time. So I started the experiment. 3 minutes into the experiment, it felt like my ears were popping as if I was walking up a mountain and getting to that certain elevation where you have to hold your nose and blow your ears. So that occurred, and there were me and 3 others in the room. My daughter was watching TV in the living room. So after my ears had popped, I had turned on my little AM radio, and I can hear the frequency in the AM radio between stations. I thought that was really neat. So we walked outside and we mapped how far it went. It went right out to the curb away from my house, maybe 100 feet. So come back into the house, shut the experiment off. 5 minutes later, my daughter's banging on the office door. And I open it up and she's crying. She's almost hysterical. Where were you guys? Where were you guys? Couldn't find you. We didn't leave the office. Not any of us, other than me and one other person. And all we did was walk outside the office door, walk through my front door, out to the curb, and came back. The living room is just off of that. So my daughter knocking on the door when we were in the middle of the experiment, opened the door and looked inside, and none of us were there.
Oh yeah.
So after it shut off the experiment and she'd opened the door crying, I asked her what was wrong. She said she looked for us, she couldn't find us. She opened the door, we weren't there, but we were all in the office.
You were resonating at such a high frequency to relative to your surroundings, you couldn't see you.
Okay, so after the experiment, I went to the kitchen and I brought my clock from my office, and I was 3 minutes different. The one that I was in, the office clock was 3 minutes faster than the kitchen clock.
Interesting.
So,
Gerald, that is really
I've got
interesting.
affidavits from all the people that were in that office that experienced that experiment, and I could replicate it tomorrow.
Very interesting.
I know exactly how to do it. I have very specific notes for it.
I would love to see that.
Yes,
I would love to see if you have put us on on live so we could see inside as well.
I've
And then
considered doing a big live experiment. Camera on the inside of the room, camera on the outside of the room, live, just to see, was it real? Did it happen? Did it happen the way that it was all documented and that we all believed it did?
If it's a time dilation thing, that could explain it too. If it's just time dilation, there's ways that could still be the case.
That she wouldn't see us in the office, even though she opened the door.
I mean, also, did you see how long in total that you were gone, or doing the experiment?
The experiment in total, I believe, was for 48 minutes.
Okay.
I have to look at my notes, but it was 48 minutes.
So it's a slight shift. Okay. Yeah, so that's not as important then, maybe. That's like some sort of phase shifting thing. I don't know. That's weird. Did she see the device?
No, she didn't see any of us or anything on the desk, and I had it all set up.
Weird.
So, no idea.
Huh.
But documented nonetheless, because I didn't know if it was important at the time or not. But we've all talked about time dilation, and the fact that the clock was off 3 minutes, very interesting to me. So, like I said, my work has to be looked at by far.
Well, I haven't gotten that far, that's for sure. So I'd be very curious to learn more. But I should probably head to bed for the night. Nice chatting with folks.
Yeah.
Thank you for coming on. I appreciate it.
Yeah. Thanks, Michael.
Cool. See ya.
Have a good night.
Good night.
Cool.
I know Nathan's itching to talk about holes. I expected a giggle out of you, brother. Come on, man. Give me something.
I'm trying to keep it together, man.
Right?
Okay, Nathan, you asked me last time about like the
magnets.
The magnets. I have it all set up, ready to show you guys. But you were asking me about the night vision goggle thing.
Oh yeah.
Yeah, it's right here. It's really cool. Like you look in it, and you could see like the greens and all the sorts of things, and it has like
see all the UFOs flying outside.
I figured if I have a little laser lighter. If I put it through the lens here and outside the other side, I wonder what happens.
I wouldn't do that. You might damage the camera.
You'll destroy your lens.
I haven't yet done it, so
don't do that.
But that was an idea. I was wondering, like, to see what happens. And then this is the other device, the one that you could see, you could look through it right here. I don't have batteries in it. Like I didn't charge it. I forgot. I thought it was charged, but it shows you if there's anything hidden, in the any camera, and also shows you if there's a frequency like a, what do you call it? If there's a listening device, or
Yeah.
if it's like an antenna,
Bugs.
and
Yeah.
yeah, and I'll
Bug
start like
detector.
yeah, and all like the little lights here will just go up and down.
Yeah.
Yeah,
It was a
just a little cool
scanner,
device.
spectrum scanner.
Yeah, I took it with me to Albuquerque when a few years ago. I went to a conference, not the Tesla conference, something else, and I went to their tower up there just to see what readings I would get. And there was like a bunch of university students up there doing the same test but different equipment. And they're like, "Oh, what university are you from?" I'm like, "I'm not. I'm just doing this like self experiment." So yeah, but the thing like
Nice.
was shaking so hard because there's a lot of energy in that next to one of those towers. The thing was like going like this, so
Yeah.
yeah. So those are two.
Are you gonna go to the top secret meeting in Texas? And
I am.
Scan
If you
them.
guys, if anybody wants to go, like, they're more than welcome because they gave me an open invite to invite all my friends. So if you guys want to come, we could put
that's
on a
cool.
really, really cool show for them, and show them what they don't know. I mean, if you
Yeah,
guys
if I'm
want.
able to make some sales or have a bonus from my job, then I'll definitely go.
Yeah, I mean, really, this is an open invitation to all of you. So,
Mm.
just let me know if you guys would like, so I can send you the details and all that stuff. It would be really cool. Yep. Going back to, let me grab my paper. Okay. So, solar system, right? Let me see how that looks. This is, I don't know. Can you
Little
guys see
higher.
it?
Yeah, hold on a sec. Let me maximize your screen there.
Okay.
All right. Go a little higher, Lulu.
Is that good?
That's good.
Okay.
Hold on.
So you've got the solar system, like the sun right here, and you've got all the little planets and all of the objects around them. Well, I think these things have whatever their core is, and the rotation changes according to the density of the planetary or whatever the whatever system it is. So this is what I did here. Let me go put this down, and let me show you. All right, let's go here. Let's see this. Hold on. All right, see this. Tell me if I need to go up higher or lower.
All right. That's good like that. Yep.
Okay. All right. See how I could. Hold on. Can you? Yeah. All right. Hold on. I gotta hold it better without disconnecting you guys. Okay. Is this good?
Yep.
All right. You see how I could control this one with this thing right here. All right. Look.
Yeah, with the magnetic field.
Yeah. Look at this. How they could change, or with this one.
Yeah, you're influencing the magnetic field. That's cool, Lulu.
Yeah. And this
Really?
is not. I'm not having
Oh,
attached
look
it to
at that.
anything.
Yep,
Yeah,
she's
but
making everything on the table move by one magnet on the other side.
yeah.
Yeah,
You
very
see?
cool. Yeah.
Okay. So that's one. My other experiment is this thing. This is more aligns your little rotation thing. You see? Okay, it
Oops.
fell. That's okay. It's not. I could always attach it back in here. This is all magnet. Oh, here we go. Because I haven't taped or glued anything yet down. I'm just using magnets to attach it, together. But this idea, if I put magnets around the little wire and I use the hanger, a metal hanger for this part.
Yeah.
It might make it rotate, or I have these little things. These have embedded magnets in them. And if I put it on here, it will create a magnetic field, which will push it.
Yeah, alter it. Yeah.
Yeah. So
Yep.
this is the other one last time, but I added the coils on here, like in between. I don't know if you see them. So
Mhm.
yeah. Yes. This is my experiment so far.
Yeah.
Yeah. This is where I've got.
Cool.
Yeah. But yeah,
Cool.
I believe the orbit of the planetary systems, they're opposites. One twist like that, one twist like that affects the other one, which twists another way affects the other one, and so forth. So
I like that magnet one. Yeah, he moves
Yeah,
one
on the
the whole
table.
thing.
Yeah,
All of
that
them
was
move. Yeah.
yeah. So you know and the bigger you go, it could go as big as you want. Like one controls the other controls the other, and so forth. So, but yeah,
It's almost like entanglement of magnetic fields.
you know. I think our solar system goes by the same laws. Bigger solar systems affect our rotation. So if anything gets tweaked, we're like, our planet is screwed. But because it's very
We could get
small,
thrown out. Yeah.
yeah.
We
Uh,
get thrown out of our orbit. That's it. Everything
I mean,
freezes.
we
Or we burn
already
up.
our planet already has sped up. A few seconds last year. So something is affecting the speed of rotation.
I think
Yeah.
that's what happened to Mars at one point in history. Maybe your theory might be correct. Something happened and Mars got pushed out
Mhm.
of the Goldilocks zone and pushed it into a further away orbit. And that's why everything dried up, all the water dissipated and everything.
Yeah,
So,
it knocked out its atmosphere. I think something hit it.
right. Yeah, either hit it or something came close by it and knocked it out of its Goldilocks zone. I think at one point in history, Mars could have looked very much like Earth. Well, different, but similar features, right? Water, hills, vegetation, all that stuff existed at one point.
I mean, with
in
all the
history.
new artifacts that they're finding, that's proving true. That yes, we did have another.
The latest one I heard is they
Yeah,
found
it's coming.
evidence. The latest one I heard, evidence of coral.
Coral.
Yeah,
Wow.
yeah,
Never heard that.
So,
That's kind of cool.
yeah. That's the latest one I heard. They found evidence of coral on Mars. Obviously, it's dead now, but at one point it was alive.
Well, did you hear about that comet that's headed on its way?
Yes,
That should be top news, I guess. Well, why isn't that top news?
because it's an
Interesting.
intelligent. It's not a comet. It's an
I think
intelligent thing.
it's a spaceship.
I don't know if it
Invaded.
is. It could be. I'll give you that, but we don't know if it is.
Okay, the speed that it's going and the emissions that it's producing, I listened to it like last night. It's not a natural object.
Yeah, I heard it's supposed to make it here
Yeah.
by October 29th. That's when
Yeah,
it's supposed
between
to.
October 29th and November 5th or something, right?
Yeah,
No, end of November, beginning of December.
I heard earlier.
What was that?
Hey,
What was that old thing?
Well,
Locked and loaded, baby. No.
what happened to Michael Perron? He got kidnapped by Men in Blacks, and nobody's not doing anything. Nobody
Oh,
cares.
no. I had to go early.
Yeah,
Yeah, he had to go to bed.
Yeah, it's past his bedtime.
Yeah, dude, I think Mars is just something blew up their moon because those little asteroid things they call a moon isn't good enough to get enough of the water to come out, man.
That's
You're not
possible.
getting enough tidal force.
That's possible, yeah.
I mean, something probably hit it, cracked it, knocked it off, chipped it, whatever you want to say, and then that went to the moon. I mean, went to the surface of the planet and probably wrecked it.
Whatever happened to it happened a long time ago.
Yeah.
Oh, yeah.
Yeah.
No,
I don't know. I don't want to go there personally.
Yeah, it's
not
much there.
Mars. I mean, there's nothing in Mars, but maybe elsewhere. Yeah, it would be cool.
Let Ellie go there. He can go there if he wants. You know that's what Elon Musk's nickname was from his babysitter when he was growing up? His nickname was Ellie.
What was it?
Ellie.
Oh.
Interesting.
Hey, know who we could send to Mars? We'll send that Simple Man 911. We'll send him to Mars.
They wouldn't have him.
Yeah. Did you guys see in the news that kid Big Balls got beat up?
I heard something.
They left Big Balls all black and blue. Yeah. They
Sorry,
it's just,
black and blue.
The fish is
He's got
bragging
blue
about.
balls now. Blue balls now.
Oh, there's so many one-liners that can come off of that.
Yeah, big balls is now blue balls.
They apparently jumped big balls and yeah, they left them black and blue.
Dead Fish is bragging about Sorfati on Jeremy Reese's channel. I mean, Sorfati, he was on my mailing list. He can't even answer simple questions.
He's
not as smart as people think he is.
You know what? He's a gatekeeper. Even if he knows, even if he's seen it, he isn't going to tell you or me a fucking thing. And Jeremy Reese, with all due respect to the guy, sure, he came out with a lot of information back when the internet, like YouTube, exploded in 2005, this, that, and the other. And then he disappeared after that. Do you guys even know why? There was a controversy around him. So for him to claim that there's no free energy and to jump on Jack Sarfati's back going, oh, yeah, it's all bullshit. We know the physics. We have the papers. Really, dude? Give me a break.
Yeah.
You know what? If you did anything, you would experiment and find out yourself. You don't want to. You're too lazy. You rely on your papers. Why? Because that's your claim to fame. Well, have a good one.
Exactly.
Because it's
somebody told me Sorfati likes to be on shows and have the spotlight, the lights on himself.
Yeah, it's 5 minutes to fame.
Yeah.
Well, everybody wants 5 minutes to fame. I've had 5. I'm good.
Yeah.
You know, who's next? Let's get everybody in there.
Yeah, exactly. Yeah, but I mean, he was on my mailing list and he can answer simple questions. And everybody's a witness. There's like 40 people in my mailing list, and they're all witnesses. And nobody wants to admit that, you know, he doesn't know what he's doing.
Or he's a gatekeeper. He wants you to think he doesn't know what he's doing.
No,
Yeah,
I think he doesn't.
If he knew what he's doing, why doesn't he have a spaceship then?
You know what? I have no respect for the man over one issue and one issue alone. MK Ultra. MK Ultra messed up my best friend for life. I knew this guy for like 25 years. So he's proud of that. Yeah, I think the guy's morals is a little off, but that's just me. I could be wrong. What a schmuck!
Schmuck.
Captain Schmuck. Isn't that what you used to say, Nathan? Captain Schmuck.
Oh, he's Admiral Schmuck.
Admiral Schmuck. That's
He's
right.
Admiral Schmuck. That's right.
5-star. 5-star. A 5-star
Five-star
schmuck.
Admiral Schmuck.
What did Bernie say? That he'd rub your grandma the right way?
Yeah. Oh, God.
Oh,
Oh, man.
Yeah, he
Oh,
was
makes
the
me laugh just thinking
hypnotist,
about
wasn't
that.
he, or something like that. Jack, that's funny. We
No,
should
but no, all the PGs from MIT, from they were all on the mailing list, and nobody is able to answer simple questions. I asked them, and then they claim, "Oh, you don't have you don't have peer-reviewed papers, so I'm not going to talk to you." Blah blah blah. You know how it is.
Didn't MIT get caught for forging one of their papers and claiming something that was bullshit? Wasn't that MIT?
Yeah, they use AI to write tons of useless papers just to get grants.
Yeah, well, get paid by the government, right? That's what everybody wants. It's guaranteed check. But are you really getting paid by the government, or are you getting paid by you and I, the ones
And
paying the tax?
who pays the government is the taxpayer, you know?
Yeah, right. Ah, well, what do you do?
Yeah.
Might as well go for a soda.
We should all become professors. That's what we need. Professors at MIT. That's what we need. We can get in on a little bit of that money.
Yeah.
Some of the gravy.
We can make a TV show out of it. It'd be hilarious.
You have, guys, if you want government money, come to that event that I'm invited. Let's see, we could pitch something. We can get government money.
I do have something to sell the government, and I'm going to be testing it probably in the next 2 months because I have to get the shooting range set up at my friend's private property. I've come up with a bulletproofing that stops a 30-06 like
Ooh.
it's nothing.
Wow.
Yeah. So if it can stop a high-powered hunting rifle, I don't know if it could stop a 50 cal. It might be able to, but once I know that it could stop a 30-06, a 30-30, I might even try an elephant gun because my friend has an elephant gun. So
Boom.
I might try that just to make sure. And if that succeeds, then I'll be interested in going to the military to have them test it further. And if it works, by all means, I'll sell it to them. Because, hey, they need bulletproofing, right? I have no problem selling protective things to the military.
Well, there
That
you
I
go.
agree with 100%.
Something tells me you just want to fire the elephant gun.
Yeah, it's
Don't tell anyone.
Gerald the elephant. Gerald the
I mean,
elephant.
I would do it if my buddy had one. If you guys are here and said, "Hey, let's do it," oh, I'm all in.
Call it
That
elephant
thing's
skin.
huge. The
Call it
bullets elephant skin. Is
yeah.
that what you're saying? The bullets on an elephant gun are massive. It's stupid. It's hilarious. I'm telling you.
It's like a cannon.
Pretty close. Yeah.
You have to have a
Oh,
strong
man.
shoulder.
I'll tell you. When I was asking him about it, he said, "I'll have to stand behind you when you fire it." I was
Yeah.
like,
Ooh.
"Really?" Like
Yeah,
I can
blows
shoot
you
a
up.
30-06. He's like, "This isn't that."
Is it gonna like push you, throw you back when you?
Yeah.
kick back.
Apparently, it'll put you on
Recoil.
your arse. Yeah, big time.
Yeah,
Wow.
recoil on that.
What's that?
The recoil must be huge on that.
The recoil, yeah, he said it'll put you on your ass. So he has to stand behind me. When I do it, I'm putting it on video. So if I hit the ground, that'll be the funniest moment ever, man. I'm telling you.
Yeah.
And I'll put it in the video. I don't give a shit, right? Laugh away. If I can laugh at myself, other people should be able to.
King
There
of
you
the
go.
holes.
King of the holes.
King of
yeah.
the holes.
That's awesome.
Dude, that is awesome.
Very cool.
I'm always working on new things. I got to keep my brain busy, man. I get bored.
Gerald, but really for real, do that experiment again. I'm really interested in, because I do have that theory, like if you oscillate something fast enough, an outside observer cannot see it because it's not in the resonance frame the same,
Yeah, what you're talking about is like phase shifting.
Yeah. So
Yeah,
I'm
phase shift.
100% sure that like a person would disappear although they're there just because of the the phase shift. Yeah.
I'm willing to set that experiment up. I've got 8 cameras now just waiting to get set up into a really good experiment, different angles. So I'm willing to do that, but it's going to take me a bit to get going because I have to finish my work that I've dedicated myself to, right? So I'm just about finished. I could show everything I've been working on instead of just talking about it because I hate that. But it is what it is right now, right? I don't want to show 4 things and have the last thing be like, "Well, I'm waiting for this part." No, I don't want to do that. I want to just release it all, show everybody what I've been working on, explain what it is it does, and then people can replicate or whatever.
But you know that movie called Dunes, the guy wears something, and if they like if he gets like if there's a protrusion, he oscillates. It's the same kind of like the concept would be the same thing because it's an oscillatory device that puts the I guess the whatever
Okay,
it
so
is.
if it works that way, would it be a form of invisibility?
Yes.
But okay, now could you even call it that? Because if you're phase shifting, you're literally no longer in that time space or space of the person that you were standing beside originally. So could it be invisibility, or could it be like, I don't even know. Would it be time warping? Like it's an interesting thought anyway.
Would it be existing in a parallel universe?
See,
Yeah.
that's a whole other ball of wax. I got to put the experiment together and recreate it before we can even think about what it could be, right?
You said 3-minute difference. That's
Yep,
a big.
3-minute
That's a
difference.
big difference. Huh?
So I don't know. It was definitely interesting. When my ears popped, I got a little freaked out because I've been in BC. I've hiked mountains. I know what it's like. So why is the pressure changing in my room, in my office? Now the walls, they were 1.5 feet concrete because I was living in a mansion. I was kind of blessed. The people that they were renting it to us lived in another province. But it was just an amazing experiment. I'll recreate it maybe in a month or two, tops 2. Yeah. And we'll do it live. And if it doesn't work, I have no problem with that. If it works, hopefully nobody else has a problem with that.
Yeah, we'll call it Gerald Warp.
Right? I'll be on camera and all of a sudden I won't be on camera. It's crazy. Who knows? We'll see.
Well, just make sure all your body parts go with you, man. You don't leave nothing behind.
Make sure they don't come back.
Yeah.
But you know, with the experiment, we're all going to be quantumly entangled with it, right? Because if it's going live, it's all connected, one form or another.
That's
So
interesting you say that because there was another experiment I did. I was running the coil. I got a phone call on my cordless phone, and it was a 2.4 gig, just your regular cordless phone. But I walked to the end of my block while I was talking to my friend and back. And I didn't realize how far I walked until I was at the end of the block. And I was like, wow, okay. So I came back, shut the experiment off, called my friend again to recreate the distance, and I couldn't even get past my driveway. So something was happening. Maybe he was extending the field. I don't know. I can only tell you what I experienced. So I don't know if that's quantum entanglement or not, but it's definitely it's interesting. That's
the same thing. You could like prove quantum entanglement. If you scream on one end, if I hear it, it hurts my ear. It's there's quantum, cause and effect. So do you understand? Like quantum entanglement is, man, they proved it that like even in telecommunications, when one event happens and if you link a call, it affects somehow the other side just by a phone call, just by uh, frequencies. So I don't know. Yeah, it would be really cool to. Yeah. Anyway.
This whole team is amazing. You guys have the brains of geniuses. I'm telling you, if all of us were in a freaking warehouse together for a week,
Yeah, but
the world, man.
The cool thing about this team is we're not stuck up in our ego up our arses, and we can work together. That's a cool thing.
And I hope you guys understand, when I talk about the stuff I'm working on, I'm not coming from a place of bragging or anything like that. I'm just telling you what I've experienced so that when I release it and release all the plans, you guys go, he said this, and this. Let's see if he's full of shit, and do the experiments on your own. Prove me right or wrong. That's what I want. I don't care about fame, fortune, or who gets it first. I just want to make sure everybody gets it.
If you try to do that experiment again, get a large wheel, put magnets on it, and spin it while you're doing that experiment.
Why?
See if you can get the fields rotating inside the room as well as creating the time dilation.
Oh, well, that's just the thing, though. The coil itself creates spin.
Yeah.
In the room itself,
but if you were able to get the wheel, find out what direction the spin is going, and then get a magnetic field on a wheel and try to counter rotate it.
Well, the coils themselves, it's literally a magnetic field that spins with a counter rotating field within it.
Oh, okay.
Yeah, once I show you the experiment and I explain everything I've been working on, you'd be like, oh man, I get it. If you can explain it to a 5-year-old and a 5-year-old gets it, then you know what you're talking about. And I explained this to my nephew just the other day. He's like, I get that, Uncle G. I was blown away, man. I'm telling you. So this stuff's for real. And when I literally release all the plans to you guys, you four, you'll be building it all on your own. You won't need me no more. I'll be a reference call. Yeah. Which way do I do? Okay, thanks. See you later. Click. That's how it's gonna be. And that's all good. I don't mind. That's what I want.
Pager.
I want everybody to work.
You'll need a pager.
A reference. It's hard to reference somebody that changes his YouTube channel all the time, or we don't even know his address. You know, I know you want to stay anonymous a little bit, but
what do you mean?
You know what
I'm
I
not
mean?
in the dark. I'm just kidding. I'm kidding.
No, but you know what I mean. It's hard
I won't
to
be anonymous
reference,
much longer. Okay, let's just say that I have to stay anonymous for now, but not much longer. When I release everything I've been working on, I'm not just releasing my work. I'm releasing myself. Full name, face, address, phone number. Bring it on, baby, because that's what I'm going to be all about.
And at the end of the list, you point out how much you bench press. So if people want to mess with you, then they know what to expect.
Oh my god, dude!
I'm not worried. I'm not worried.
No, but the Men in Black or something like that. Huh?
Yeah, bring them on, the Men in Black. Put them into the Men in Pink.
Yeah, just booby trap the whole house.
Shh, don't tell them my secrets.
Oh, did you ever see? Did you ever see that? I think it was on Facebook or whatever. It's like in England, right? And these two Jehovah Witnesses come to the door and say, would you like to talk about the Lord and how Lord's salvation, all this kind of stuff? And the guy goes, "Oh yeah, come with me, come on in." So he invites them in, and he goes, "Yes, come this way." And he goes down this hallway, and he goes, "Okay, just go through that door, and I'll be with you in a second." They open the door, and it's a cliff.
Nice.
Oh, it's hilarious. It's like English humor, but it's so awesome.
That's good. I love English humor.
Oh, it's hilarious.
Mr.
Monty
Bean.
Python.
Monty Python, yeah.
Oh man.
When he gets his leg cut off, I'll still get him. Get over here. Gets his arm cut off. I'll bite you to death. I'll get you.
Or history of the Earth Part 2.
Oh yeah.
This kid's walking around. It's like in the Victorian era. So he's walking around with this bucket. It's called the piss bucket. So if you have to take a piss, he holds it for you. And the guy takes a piss in the bucket, and then he flips a coin and it lands in the bucket.
Have you guys seen the YouTube jokes about a guy that has a monkey in his trunk? So when he gets into trouble, he releases the monkey.
I seen that. That's hilarious.
At some point, you got kids that throw eggs on the car, on the somebody that drives a car.
Security. Yeah,
and then he press a button, open the monkey trunk, and then the monkey goes after the kids.
Oh, cool.
That's
anyway,
funny.
so I think we're gonna wrap it up for tonight. I'm pretty tired. I'm getting the sleepy eye going here. So we go live to air again next Friday at 9:00 Eastern. The week after, what is it? The 29th, Philip?
29th? Yeah, the 29th. Yeah. But I'm not going to be there next week. I don't think so.
Yeah, the 29th I'll be in Calgary. So, but next Friday, I'll do a show next Friday, and then the week after there won't be a show. But the first week going into September, we'll go back live as usual on Friday nights.
You gonna do a show with Bernie when you're in Calgary?
That's if I meet up with him. My itinerary is pretty busy, so we'll see what happens. See if I got time to meet up with him. I'm supposed to do quite a bit of traveling when I'm there. I'm going to go to.
So is he in Calgary or in Edmonton?
Yeah, he's in Calgary. Yeah.
Is he still in Albuquerque, or is he back?
I think he's supposed to be on his way back soon. Yeah. Yeah.
I think he's
Yeah.
back already, isn't he?
He's supposed to be back, I think, this weekend. Yeah.
Yeah.
I think
So,
he was hanging out with Aiden Schaefer. Aiden
Yeah.
Schaefer was one of the first people that were part of APEC.
Yeah, I
Oh.
remember.
You know, yeah,
Oh,
and
okay.
then he just, I don't know why he left, but I met Aiden in person. So very intelligent human being.
Nice.
Then he just disappeared, from
Okay.
APEC.
Lulu, she knows
Well-
everything, and that's pretty interesting.
Guys,
Well-
stay on after we go off the air here. Everybody, thanks a lot. Chat was great. We'll see everybody next Friday. Take care.
Goodbye,
Hey,
everyone.
everybody.
Take care.
Goodbye.
Bye.